Hey y'all, let me just start this video by asking a question. What is the closest planet on average to Earth? Now, if you know the order of the planets, you might have narrowed it down to either Venus or Mars. And if you've seen a picture of what those orbits actually look like for the inner planets, you might think that Venus is the closest to Earth. Indeed, if you Google the question, you'll often find answers just like this. Most people correctly say that the distance between Earth and each planet changes from time to time, but if you average it, the closest planet is Venus. You can find lots of examples of educational organizations saying something like, Venus is our closest neighbor. Sometimes they're directly addressing the question, but a lot of times it's just something that they mention on their way to talking about Venus. And in fact, several organizations have even gone far enough to tabulate what they call the average distance between each pair of planets. And they all agree with each other, and if you look at them, the average distance between Earth and Venus is smaller than any other planet. But here's the thing about that. I got a bee in my bonnet one day and started doing the math, and I could not replicate these results. What I kept finding was that Venus was not our closest neighbor, but in fact Mercury was the closest planet to Earth on average. Some friends and I formalized that math into what we call the Whirly Dirly Corollary and published it in Physics Today. I'll link that in the description. But at this point, you, like me at the time, are probably just thinking that the math was wrong. So I built this little simulation of the solar system. Let me go ahead and get that started for you, and then as the video progresses, I can explain the parts as we go along, and you can go back in the video if you want to look at any particular part in detail. If you look to the left there, what you see is actually a map of each different planet. Of course, Mercury is gray, Venus is orange, Earth is blue, and Mars is red. You can just see them circling the sun there, and these are true positions which are being plotted. You'll see the date at the very top, and then you can also see how many days have elapsed since the start of the simulation. So let me go ahead and toggle on some lines here. These lines you'll see are radiating out from Earth, and they're illustrating the distances that we're measuring. So the gray line is from Earth to Mercury, the orange one is from Earth to Venus, and the red one is Earth to Mars. And what we're going to do essentially is every day we'll measure what that distance is, and then we're going to take an average of all those distances to see which planet really is closer. So the most important thing here is really the bottom right there. There's two different graphs. There's a bar graph and a pie chart. And those are showing two different things. One is showing the distance from Earth to these various different planets. That's the bar graph. The blue is showing the average over all of these days, and the green is showing the current value. So you see that green value fluctuate all the time throughout the year, where the blue one is just going to kind of settle out as we get more and more days average. That's going to get to be a more and more concrete number. And on the right, what you see is the time that particular planets have spent closest to Earth. Interestingly, SciShow Space once made the offhand claim that Venus is usually the closest planet to Earth, but keep an eye on that bottom right chart to see if that's really true. Now these charts are just plotting the numbers above them. You'll see listed in kind of a table there. We've got the planet, the distance from Earth, the average distance from Earth, and then the percent of the time that it is closest to Earth. So you'll see those numbers fluctuating pretty wildly right now, but as the simulation goes on, the averages will get more and more concrete. And then at the top there, what you see is just a time history of each planet's distance from Earth, and then you'll see a dotted line on top of those, and that is the average of those values. And so if you look at those, you see red on top. That means that Mars is on average the furthest. Then you'll see Venus in orange, and then gray is just below orange. Gray is that's Mercury, and it's a little bit closer to Earth on average. It's really interesting. Similarly, on the bottom now, you'll see it's starting to even out. If you look at those blue bars, the blue bar for Mercury is just a little bit lower than Venus. And if you look at the table, the DFE average, Mercury is around 1.04 on average, and Venus is going to average out around 1.14. So that's like a 10% increase in distance. And then, of course, the time spent closest to Earth is really not even close. Mercury is the closest planet to Earth a lot of the time. So you can just watch this simulation play out and watch all these numbers slowly settle to their final true value. I also want to mention I actually ran this simulation for a period of about 10,000 years. I'm just only showing these 50 because generating the graphics is a little bit burdensome. I'd also like to talk a little bit about the methodology of how I actually got these numbers. So the planets on the left there are being mapped using a Python library called PyFM. That's PYEPHEM. And that's just an astronomy library that you can use for Python. And I want to mention, this is my first time using that, so I actually had a friend check my math. He used, he does this sort of calculation for a living, and he used, I think, their own proprietary software to run these calculations, and actually he got the exact same answers. So that gives a little bit of validity to it. But anyway, so I used PyFM to plot the positions of the planets, and then all the values that you see tabulated on the right are values that I actually calculated. So the distance from that planet to Earth, and the average distance, of course, is just the average of all those collected over the time period. One final thing I'd like to mention is that in the 10,000 year run that I did without generating graphics, I went ahead and averaged the distances between every pair of planets to compare to the published results I showed before. What you see tabulated here are the simulation results compared to those previously published solutions, which I'm calling the old method, and also the mathematical method that I derived, which I call the point circle method, or PCM. You'll see that the PCM tracks much more closely with the simulation results, and in fact the simulation results only deviate from the PCM by at most 1%, while the simulation deviates from the old method by at most over 300%. So I think this makes it clear that the PCM is a much more accurate method for determining the average distance between two planets. And what is also very interesting to note is that not only is Mercury Earth's closest neighbor, it is actually the closest neighbor to every other planet in the solar system. Anyway, that's about all I've got. I hope that this has been convincing and educational, and if you have any thoughts or comments, I'd love to hear them. Thanks so much for watching, and I'll catch y'all next time.